Welcome and thank you for joining this webinar, The Architecture of Autonomy, Distributed Artificial Intelligence as a Native Capability of Future Wireless Networks, prepared by the Alpert Research Team. Wireless networks are entering an era where complexity, scale, and performance demands exceed what centralized control can manage. Distributed artificial intelligence enables networks to sense, learn, and act autonomously across devices, edges, and cores.
But the report immediately throws a lot of alphabet soup at us. We see FL, MAS, Edge AI, Swarm Intelligence. I think we need to break these down. It feels like they're the different flavors of DAI.
That's a perfect way to put it. Let's call it the taxonomy of autonomy.
I like that.
Let's start with the one that's probably the most mature and people might have heard of, Federated Learning, or FL. The mantra for Federated Learning is really simple. Bring the code to the data, not the data to the code.
So my personal data, it all stays on my phone.
It never leaves your phone. Let's take a network example. Carrier wants to train a model to predict network congestion. In the old world, your phone would have to upload all its raw signal strength logs, data usage, everything to their central server.
Which is a huge privacy concern.
With Federated Learning, the process is flipped. The carrier server sends a small generic baby model down to your phone. Your phone then trains that model using your local data, making it just a little bit smarter. Your phone sends back only the mathematical update. It doesn't send your data, it sends the lesson it learned from your data. It sends the gradients, the mathematical direction of improvement. The central server then aggregates millions of these tiny updates from millions of phones to build a much smarter global model, which it can then push back out to everyone.
So FL is really about collaborative learning while preserving privacy.
And does it actually work in the real world?
The report is very clear on this. It cites healthcare pilots that achieve accuracy within 5% of traditional centralized training. So you might lose a tiny fraction of precision in some cases, but the privacy, security, and compliance gains are absolutely massive. For regulated industries, it's becoming the only viable way to do large-scale AI. That sounds perfect, almost too perfect. What's the catch?
The catch is a big one. It's something statisticians call non-IID data.
Non-independent and identically distributed.
It basically means the world is messy and your data is not like my data. Maybe you're a doctor, so your phone's keyboard learns a lot of medical terminology. I'm a gamer, so my phone learns a bunch of video game slang.
So our data is skewed.
If the global model learns too much from your doctor update, it might start trying to autocorrect my gaming slang to medical terms. When the server just blindly averages all these skewed updates, it can create a Frankenstein model that is actually bad at everything for everyone. So a huge area of research right now is personalized federated learning. The idea is essentially you keep a local layer of the AI that stays customized just for you, while the more general base layers of the model are shared with the world. It's like having your own personal dialect of a global language.
That makes a lot of sense. Customization at the edge. The report dives a little deeper into the architecture for federated learning, specifically mentioning hierarchical FL. Why not just have all the devices talk directly to the cloud?
It goes right back to that communication bottleneck we started with. Imagine 10 million smartphones all trying to send their model updates to the same cloud server at the exact same time. You'd completely saturate the backhaul links. It's not scalable. So hierarchical federated learning introduces that middle management layer. The devices in a neighborhood send their updates to their local edge server. That edge server then aggregates the updates from maybe 1,000 devices, averages them out, and sends a single compressed update up to the cloud. It acts as a funnel or an aggregator, saving a massive amount of backhaul bandwidth.
That's incredibly smart. It distributes the communication load as well as the computation load. I want to go back to the learning part. With federated learning, you said the devices send math, not data. The report calls this distributed optimization. The core algorithm is called FedEv,
which stands for federated averaging, and it's powered by a process called stochastic gradient descent, or SGD. Imagine a huge mountain range shrouded in a thick fog. The goal is to get to the absolute lowest point in the entire valley, because that lowest point represents the perfect model with zero error.
Okay, so we're trying to get to the bottom, but we're blind because of the fog.
The only thing the hiker can do is feel the slope of the ground right under their feet. That direction, that's the gradient. So the hiker takes one small step in that downhill direction. Now, in FedAg, imagine you don't have one hiker. You have millions of hikers, all the smartphones, and you drop them on random different spots all over this foggy mountain range. Each hiker on their own phone calculates their local gradient based on their local data. Then they all report their new position to a central coordinator. The coordinator averages all of those millions of individual steps together to find the best overall direction for the entire group to move. It's like finding the average opinion of the crowd. It then sends that averaged update back to all the hikers.
So by repeating that process, the entire swarm of hikers slowly makes its way down to the bottom of the valley together.
And they find it much faster and more robustly than any single hiker could on their own. They're literally crowdsourcing the search for the optimal solution.
Distributed artificial intelligence is central to the evolution of 5G Advanced and 6G, redefining how wireless networks are designed, operated, and trusted in the autonomous era.
It really is the future of the field.
And if you are interested in gaining a deeper understanding of the transformative power of wireless technology, the Alpert Research Team runs webinars where they explore these cutting-edge wireless innovations, their applications, and their implications. We encourage you to click the links below to learn more.
It's well worth your time if this topic is interesting to you.
Thanks for listening. We'll see you next time.